For the first three problems in the Chapter 12 test review, we are going to use long division to divide polynomials. So if we have x squared plus 12x plus 35 divided by x plus 7, we want to put the x plus 7 outside of the division box and x squared plus 12x plus 35 inside. Then we ask ourselves, what do we need to multiply x by to get x squared? And that is just an x, and we want to take that x and put them over the 12x. Then we want to distribute and multiply x by x plus 7, and we get x squared plus 7x. And now we want to subtract by changing the signs. And the first two should always cancel, and we have 12x minus 7x, which is 5x. And we want to take the 35 and drop him down. Now we do the process all over again. So we ask ourselves, what do I need to multiply x by to get a 5x? And that would just be a positive 5. And then we take that and we distribute. And that gives us 5x plus 35. And now we want to change the signs. And when we combine it, we get 0. So there's no remainder. So our final answer is just x plus 5. For number 2, we can see that the problem starts off a little bit out of order. So before we divide everybody, we want to write the first one and the second one in order. So let's put z squared first. So we have z squared plus 4z minus 1 divided by z plus 5. That will help us keep everything straight. So the z plus 5 is going to go on the outside, and the inside will be z squared plus 4z minus 1. And we need to multiply a z by a z to get a z squared. And then we want to take that z and multiply them by z plus 5, which will give us z squared plus 5z. And now we want to change the sign. And we end up with negative z. And we want to take this 1 and drop him down, minus 1. So now we need to multiply z by a negative 1 to get the negative z. And then distribute the negative 1. So we have negative z minus 5. And then change the signs. And so we end up with a 4. So since we have nothing else to drop down, 4 is our remainder. So for our final answer, we're going to write a plus sign, and then 4 over z plus 5, since that's what we were originally dividing by. So that is our final answer. For number 3, we have 3a squared minus 2 divided by 3 plus 3a. So we notice that in the first one, we're missing an a. So we want to rewrite it as 3a squared plus 0a minus 2. So we can fill in that gap. And then we want to take the second one and write them in order as 3a plus 3. So now we have 3a plus 3 on the outside and 3a squared plus 0a minus 2 on the inside. So to get 3a to become a 3a squared, we need to multiply him by an a. And then we want to take that a and multiply 3a plus 3. So that gives us 3a squared plus 3a. And now we want to change the signs. So we have negative 3a and drop down the 2, minus 2. So now we need to multiply 3a by a negative 1 to get a negative 3a. So that will give us negative 3a minus 3. And now we want to switch the signs. So we're left with 1. So 1 will be our remainder. So we're going to write a plus sign and then 1 over 3a plus 3. And that is our final answer. Now we're going to work on simplifying expressions and stating the excluded values. So for number 4, we have 16x to the 5th over 4x to the 3rd. So we can cross the 4 out with the 16, and it goes in 4 times. And we have an x to the 5th on top and an x cubed on the bottom. So we remember that we can subtract the exponents. So we can cross x to the 3rd off, and the 5 will become a 2. So we're left with 4x squared. So now to find the excluded values, we take what we originally had in the denominator, which was 4x cubed, and set it equal to 0 and solve. So if we divide by 4, we get x cubed equals 0, and x will just equal 0, because if you multiply 0 by itself 3 times, you get 0. So our excluded value is x equals 0, and our simplified expression is 4x squared. So for these problems, you'll need to show both answers. For number 5, we want to see if we can factor before we can cancel anything. So we have 3y minus 15, and you'll notice that you can take a 3 out of 3 and 15. So we'll want to rewrite the numerator as 3 times y minus 5. And the denominator, it's pretty close to y minus 5, but not exactly. If we wrote it as negative y plus 5, we can see that we can take a negative 1 out. That'll make the y positive and the 5 negative. But the negative 1 needs to come out first. So now that we took out a negative 1, we can cancel out our y minus 5's, and we'll just be left with 3 divided by negative 1, which equals negative 3. Now for the excluded values, we take what we had in the denominator originally and set it equal to 0. So if we just add y to the other side, we'll get that our excluded value is y equals 5. For number 6, we want to factor in order to simplify. So for the numerator, we want to find two numbers that multiply to 77 and add to 4. So that would be 7 and 11. And we would want the 11 to be negative and the 7 to be positive, so they add to negative 4. And then in the denominator, we want to find two numbers that add to 22, that multiply to 22 and add to negative 13. So two numbers that multiply to 22 are 2 and 11, and they would both need to be negative to add to negative 13. So since we have a z minus 11 on top and a z minus 11 on the bottom, we can cancel those. So we end up with z plus 7 over z minus 2 as our simplified answer. So now to find the excluded values, we go back to the original before we canceled, and we set it equal to 0. So we take both our factors, z minus 2, and set it equal to 0, and z minus 11. So our two excluded values will be z equals 2 and z equals 11. For number 7, we want to multiply the two rational expressions together. However, before we multiply, we want to factor to see if anything will cancel first. So if I'm working with the first fraction, I'm going to try to factor r squared minus 9r plus 18. So we want to think of two numbers that multiply to 18 but add to negative 9. So 6 and 3 multiply to 18, and if I make them both negative, they'll add to negative 9. And then we want to factor the denominator. So if I have 30, 5 and 6 multiply to 30, and they add to 11. We can't factor r plus 5, so we'll just leave them be. R squared minus 36 is a difference of squares, so that'll factor into r plus 6 and r minus 6. Now we can see what will cancel. So we have an r plus 5 in the denominator and an r plus 5 in the numerator, so we can cancel those. We have an r minus 6 in the numerator and an r minus 6 in the denominator, so we can cancel those. We cannot cancel anything else. Even though we have two r plus 6's, they're both in the denominator. So our final answer is going to be r minus 3 over r plus 6 times r plus 6. For number 8, we want to divide two rational expressions. So if you are working with fractions and you're dividing, what we want to do instead is multiply by the reciprocal. So we're going to leave the first fraction the same, s squared plus 3s minus 10 over s squared minus 9. And we're going to turn the sign into multiplications and flip it around so we have s plus 3 over s minus 2. So now we want to factor to see if anything will cancel. So if I factor the numerator of the first fraction, I'm going to have s, and if we have a negative 10, we'll need a 5 and a 2. And since we have a positive 3, we'll want a positive 5 and a negative 2. S squared minus 9 is a difference of squares, so it'll factor into s plus 3 and s minus 3. And we cannot factor the second fraction, so we'll just leave him be. So now we can see what will cancel. So since we have an s minus 2 in the numerator and an s minus 2 in the denominator, that will cancel. And an s plus 3 in the denominator will cancel with the s plus 3 in the numerator. So we're left with s plus 5 over s minus 3 as our final answer.